Today we're going to be talking about how to use random samples to help us describe populations. Okay? This gives us a more accurate view of what the population does. Okay, so how does this differ between what we were doing before? Instead of one random sample, we're doing several random samples. Okay? And what's a random sample again? What's another word for random? Shout it out. Unbiased. Good. Okay, unbiased. And that means what? Go ahead. Okay, accurate. There's no favors. Okay? We're not playing favorites when we're asking or trying to find our data, right? Okay? Completely unbiased. All right. So, our objectives are to use multiple random samples in order to make conclusions about a population, and also to use those random samples to help us examine the variations in our estimates. Variations meaning the differences, okay, between each of our estimates. Let's take a look at an example. You and a group of friends want to know how many students in your school prefer pop music. There are 840 students in your school. Each person in your group randomly surveys 20 students. The table shows the results. Now, when you're using random samples to describe populations or make estimates, you have to make sure those random samples are equivalent. Okay, so that's why you and your friends had to ask 20 random students. Okay, so here's our results. You found that 2 people liked country, 13 people liked pop, 4 people liked rock, and one person liked rap. Okay, that's how you read this. So first, we need to use each sample in order to make an estimate for how many students in the school prefer pop music. Each and every single person who does a random sample needs to have their own estimate. That's what that means. Okay, and how do we predict? Let's do a quick review. How do we predict again? What do we do to predict something? Come on. What's prediction? Emma, this is from probability, our last chapter. Exactly. Take what we got in the first place, take the probability that we got, and then multiply it by how many we're guessing about, what our prediction is going to be about, okay? So let's take a look at us, you, okay? 13 people liked pop music. We need to know how many students in the school prefer pop. How can we predict? What would we take? What's what we know? What's that fraction that we know like pop music? 13 over 20. Okay, and what are we going to do with that? Times it by? How many students are there? 840. That's how many we want to predict for, right? Okay, we want to guess how many out of the 840 students like pop. Okay, so that is our math problem. Somebody calculating it for us? Go ahead. And you get 546 is correct. Okay, that's what you got for an estimate. Now let's do each of your friends. So how many estimates are we going to end up with? 5, good. We're going to end up with 5 guesses. Okay, do friend A. Friend A found 8 out of 20, so times that by 840, and we get 336. Okay, what about friend B? 420, friend C, 420, and friend D, 378. Nicely done. Okay, so we have 5 guesses. Well, these guesses are very varied, right? Okay, we've got one that's 336 and one that's 546. There's a big difference there. What is the difference exactly? So let's calculate the range. And that'll tell us a little bit about our population here in our samples. So what's the range? Let's calculate the range. The range of our estimates is, good, 210 students. Okay, there's a difference of 210 here. What does that tell us about the population, about our samples? Are they accurate individually? Are these samples, would you consider these samples accurate if we just picked one at random? No. That tells us that we need to do something further to gather a more accurate estimate. And that's where we use those random samples to help describe those populations. Okay, so we're going to use our guesses, our estimates, and we're going to find the measure of center from them to make it even more accurate of a number. Okay? The question is, which measure of center would be best for this data? We have mean, median, or mode. Well, let's start with mode. Is more than 50% of our numbers the same number? No. So we're not going to use the mode. Okay? Mean or median? What do you think? Did you have a thought? No? Okay. When do we use the median? When there's gaps or a gap. Do we see a gap in our data? Right? There's lots of gaps there. So the median would be more preferable over the mean. So what is the median? In order to find the median, put the numbers in order and find the one that's in the middle. And you get 420. That is our most accurate estimate for how many students like pop music in this particular school. Okay? That's the most accurate estimate from what we have gathered in our data. Does that make sense? All right, now let's give you a try. It says, you and a group of friends want to know how many students in your school prefer pop music. There are 840 students in your school. Each person in the group surveys 20 random students. The table shows the results. First, we're going to use these samples, each individual samples, and we're going to make an estimate for each of those samples. Okay, so how many estimates are we going to find? 5, right? One for you, one for friend A, friend B, C, and D. Okay. After that, we're going to describe the measure of center and the variation. We're going to use the median here and find me the range. Okay. Go ahead and pause the video, and when we come back, I'll give you what the answer should be. All right, so now that you have tried this on your own, here's what you should have gotten. Your individual estimates are 42, 84, 42, 42, 126. What is another measure of center that we could have used here? What's the other measure of center that we could have used? We used the median. Another more accurate measure of center would have been the mode. Why? Because 3 out of 5 of the numbers are the same. Okay? If that happens, if there's 3 numbers out of 5 that are exactly the same, the median and the mode are going to be the same every single time when there's 5 numbers. Okay? So it really doesn't matter. All right, here we go. And the range would be 84. Oops. Okay. Now let's talk about how we would use random samples to help us estimate an average of a population. Okay? So in this example, you want to know the mean number, the average number of hours students with part-time jobs work each week. At each of the 6 schools, you randomly survey 10 students with part-time jobs. Your results are shown, as in this is how many hours each week each student said. So the first student at the first school told you, hey, I work 6 hours a week. Okay? So on and so forth. Use each sample to first make an estimate for the mean number of hours students with part-time jobs work each week. And then we're going to describe the variation of the estimates. Sample A, our random sample A, the mean of that, okay, those 10 numbers, 6 plus 8 plus 6 plus 6 plus 7 plus 4 plus 10 plus 8 plus 7 plus 8, divided by how many? All right, so we have 70 divided by 10 equals, okay, the mean, the average for random sample A was 7. Now we're going to calculate the average for each of the others. Okay. The sum of B was 73, so 73 divided by 10 is 7.3. C was 77 divided by 10 is 7.7. D, if you add them up, you get 50, and there's 10 numbers, so 50 divided by 10 is. E, you get 80, so 80 divided by 10 is. And the last one, F, when you add up all these numbers, you get 90, and 90 divided by 10 gives us an average of 9 hours a week. These are the averages for each random sample. Okay? Those are the averages for each random sample that we gathered. Let's describe the variation. What is a measure of variation that we've been using the most? Range. Okay? So what is the range of these values? We need to see if this is accurate data. Are these means close together in proximity? So good. The range is 4. Okay. Would you say that our data is fairly close in proximity to each other? Yes. Okay. So far, so good. Now we're going to use each of these samples and we're going to make one estimate. I have 6 schools in a district and I want to tell my public about, on average, how many hours a high school student works during the week. I've surveyed each individual school. I found the average for each individual school, and now I want the community average. Okay, I want one value. So what we're going to do is we're going to take the averages and we're going to find the average of that. Does that make sense? To put them all together into one average, we just take what we got and we find the average of that. Okay? And you get approximately 7.3 hours. Another way is to literally go up and add all of these guys together and divide it by, well, let's see, 10 times 6 is 60. Find the average of all of them, right? Okay, it's the same, one and the same. You would get 440 divided by 60, which is still 7.3. Repeating. Okay, so we estimate that students with part-time jobs work on average 7.3 hours a week. Whoops. Why don't you give it a try here? So pause the video, try these problems. I'll be back with the answers. Here is all of your data. For each sample, you would have found the median or median number of hours. Okay? Median. It says an estimate for the median. Okay? So we got to read carefully, and median means we're going to put them in order, find the middle. Okay? Put them in order and find the middle. Good. So you would have gotten 4.5, 7, 7.5, 8, 8.5. Okay? Measure of variation, our range. Well, we got 8.5 and 4.5. What's 8.5 minus 4.5, class? 4. Okay? And then we're going to use all 6 samples to make one estimate for the median number of hours students with part-time jobs work each week. So we're focusing on the median in this problem. How would we do it? We take our estimates, we find the median of that, which is you got 2 numbers in the middle, correct? Okay, take the average of those. That's one way. Or you can put all of these numbers in order and try and find the median that way. Questions? All right. So our objective today was to make sure we use the multiple random samples to make conclusions about a population. What the averages might be, what the median might be, okay? Measures of center and the range. And then we use those random samples to examine the variations in our estimates to see, hey, are our estimates okay? Are they close together? Hey, is this accurate or not? Kind of deal.